All right, let's try again here. So question number one from the quiz here. I think, again, you guys did fairly good on this, so I won't spend a great deal of time on this. A truck traveling at a velocity of 33 meters per second due east comes to a halt by decelerating at 11 meters per second. Sorry. The biggest issue was that many people didn't take that 11 and change it to negative 11 because it's decelerating. How far does the truck travel in the process of stopping? What's the velocity of the truck when the truck has traveled 23 meters after beginning to slow down? And how many seconds does it take to stop? So this is my initial velocity, this 33. We are, and it comes to a halt. So we know the final velocity is 0. I had several people, I think it was this one, where the VI and the VF were backwards. Yes, that's true.
What about number 2? I used it again, and it's correct.
There are ways, but let me go through them, Nate, okay? And then maybe you'll see the errors of your way. Okay, so for part A, all I did was go VF squared equals VI squared plus 2AD. And several of you did this, but you had the wrong things in the wrong places here. Peter, you should be getting these down, right? Okay, good. Okay, so VF is 0. Lots of people had those backwards there, right? The VI is 33. 33 squared plus 2 times minus 11. And again, there was lots of people that had that. They had these backwards and they had this backwards, and it sort of worked out for you. Okay, times D. And when you solve that, that's going to be D equals 49.5 meters, right? And you should be able to solve that. If you're having trouble with the math, then let me know. Okay, we need to fix that. I'm not going to go through that with everyone.
49.5 meters.
Yes, and again, Nate, as I said, if you switch these two and you didn't use minus 11, it would work out for you. I said that. If you had these switched, Nate, and you didn't have minus 11, it would work out. I've said that. 2 ears, 1 mouth, you should do the same proportional speaking and listening. You have 2. Use your ears twice as much as your mouth, Nate. What is the velocity of the truck when the truck has traveled 23 meters after beginning to slow down? It's traveled 23, so we know the displacement, right? I need to get this guy out of the way. So again, I'm going to go VF squared, VI squared, QAD. No, part B, what is the velocity of the truck? We're trying to find the final velocity after a displacement of 23. So we're solving for VF squared. The VI is our 33. 2 times, again, minus 11. Displacement is that 23. You have to do square root, and you should get 24.1 meters per second. How far does the truck travel in the process? Oh, sorry, B. What is the velocity of the truck when the truck has traveled? Okay, the last one. How many seconds does it take to stop? So I used part C. VF equals VI plus AT. There was one person, I can't remember who, that I wrote something on here. I can't remember who it was. Was it you, Kurt? Okay, yeah, use this one, man. What's the final velocity? 0. What's the initial velocity? 33 plus minus 11 times our time. So that's going to be minus 33 divided by minus 11, or 3 seconds.
I got 2. I should have got 2 and 3 for that. I got 2 of those values
right. I recorded the marks, but they're not counting towards anything. I am giving you feedback on how I want it done, Nate. you should look at it and say, oh, okay, now I get it, Mr. Bennett. Instead of arguing over marks that don't count, because it doesn't matter. That's the second one. Nate, did you have like Red Bull on your Cheerios this morning or something? Sorry to hear that. Okay. Okay, Nate, I've let you have your little conversation there while I was working, but now it's my turn. Okay, so this is part two. Most people did okay here. There's two parts to this, really. Suppose a car is traveling at 12 meters per second and the driver sees a traffic light turn red. After 0.51 seconds has elapsed, the reaction time, the driver applies the brakes, and the car decelerates at 6.2. Again, that's going to have to be negative. What's the stopping distance of the car as measured from the point where the driver first notices the red light? Okay, so here's the car, the poorly drawn car, right? As it's beginning to stop, there's actually two parts. Is it decelerating the entire time? It is not. During this time here, in the time it takes for the person's foot to get to the brake, we call that the reaction distance. You probably learned about it a bit in grade 10, right? So during this time, the acceleration is 0, and here, Nate, the average velocity is, the constant velocity is 12, okay? So there's no deceleration there. So it's simply a matter of going v bar equals dt. So it's going to be 12 equals our displacement. The reaction time is 0.51 seconds, which gives us a displacement of 6.12 meters. 6 meters just to get your foot onto the brake. From here to the back of the wall, back of the room. 6 meters. Then during this time here, in the middle, the acceleration is minus 6.2. Nate, what's the initial velocity in this period? How fast is it going right here? 12. How fast is it going at the end? 0. Okay, so I'm going to say Vf squared equals Vi squared plus 2AD. Nate, people are trying to concentrate. Please, if you can't sit and listen, then you're going to have to just, because you're distracting people, including myself. It's very hard for me to teach when I hear all this. Initial velocity is 12. Minus 6.2. Solve for D. You get a displacement of 11.6. I can't remember exactly what you did wrong there, but I know there was... Oh, okay. Silly mistake. And then what do? Add those two displacements together, right? So I would say something like dt, displacement total, 6.12 plus that 11.6 meters, and you get 17.7. You get 17.72 meters, technically. Okay? Most people in the room, and certainly those guys out there, for the most part, you know, you're in the 4 out of 6, 5 out of 6 range, right? Any mistakes you made were silly little things. But do watch that deceleration stuff. Okay, now the backside is another matter. Okay? Again, I'm really not a big fan of that different perspective. It works, but when you guys set it up, I didn't understand your logic. It's just a value. I don't know where it comes from. But okay, so then you come on up and explain it to me then, because I don't get it. Would you like to talk? Oh. Okay. The speeder is stopped. And what? Okay, so how did you come up with that equation? But how did you come up with 1.8 t squared minus 27.8 t is equal to 0? How'd you come up? But how did you get it? Like, I don't understand. Displacement is 0. But you guys didn't include your solution, right? So if you're going to do something like that, you gotta give me your logic. Yeah. Ah. It gets to his perspective. Okay. That's why it's 0. That makes sense to me. Can I do it my way? Okay, good. You want to see it my way, Kurt? Okay, good. Okay. So what I said was they are both, when the cop starts, Nate, they are both at the same position, right? So here's, I'll just label them S and P for police. Speeder and police. They're both at the same position, right? But this guy's initial velocity is 100, which is really, and I want you to show this, divide by 3.6. Please show me. Just show me you know how to do it. 27.8. Right? So his initial velocity is 27.8. The police initial velocity is 0. Right? Now, does the speeder change speed at all? Constant, right? So we could actually say average velocity 27.8. Constant velocity 27.8. Acceleration is 0. The police, the acceleration is 3.6? Okay. And the police catches the speeder when their displacements, when their positions are the same, right? So like that's what I'm saying, is you should really show that, right? Police catches speeder when positions are equal, right? That tells me your thought process, your thinking. Okay, so the position of the speeder starts at 0, so it's basically its displacement, right? Position of the speeder is equal to its displacement, which is equal to, at a constant rate, v bar times t. Right? V bar times t, moving at a constant rate, which is 27.8, but we don't know the time. Okay? So position speeder PS is equal to 27.8. That's what I was looking for. What about the position of the police? T police. Again, initial, there's no head start or anything, so it's just its displacement. There's no any, we don't have to add on any position. P police, position of police is equal to displacement. And because the police is accelerating, that's going to equal VIT plus 1/2 AT squared. VIT plus 1/2 AT squared. Do you have a copy of this, Gemma? No? Did you hand it in yet? No. For me? Oh, you didn't, but you do have it? But you didn't do it. Okay. 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 So what's its initial velocity of the police there, Nate? 0. Do I have to put t in? 0t? 0t is 0, right? Big fat 0. 1/2 AT squared. So it's going to be acceleration 3.6 t squared. Can I simplify that? For sure. 1.8 t squared. And again, so that is my position police. I don't know, man. I couldn't figure it out. The police catches a speeder when those positions are equal. So what do? We set them equal, and it would be real nice if you wrote PS is equal to PP or something along those lines. Tells me what you're doing. Right? The position of the speeder is equal to the position of the police when he is caught. Does that make sense? Well, yeah. Okay, so the position of speeder is that 27.8. T is equal to this thing right here, which is 1.8. And man, this is hard to write on. 1.8 t squared? Maybe. Does this make more sense to you? And you're absolutely right. You get the same quadratic, right? But I couldn't follow your logic. It didn't. You guys didn't give me enough information. If you'd given it to me, I probably would have figured it out. So now I'm going to set that equal to 0 on one side. 0 equals 1.8 t squared plus 27.8 t. And you should recognize that you can factor that. If you haven't done pre-calc, right, then you might have trouble factoring. Will the quadratic formula work? Absolutely, but it's pretty easy to factor, right? You factor out a t. Oh, minus. Thank you, Kurt. Yep. Thank you. Minus. Yep. Good, good, good. Okay, so 0 equals t. And actually, I want to talk about this factoring here. Just let me finish your call, and then I might answer your question. 0 equals t times 1.8t minus 27.8. So in other words, when t equals 0 or t equals 27.8 divided by 1.8, which is 15.4 seconds, right? Not meters per second. Seconds. So what's happening here is their positions are the same at 0 seconds or at 15.4. He catches them at 15.4, but their positions are the same at 0. How come? Because they're both at the same spot when the timer gets started. This is a slightly different one because the other one we did, Fred and Barney, they were like this, right? They were head to head, right? There was that offset kind of thing. Right? When the next one that we did, Jack was catching the bus was ahead of him, right? But here, it's two vehicles, two things that's starting at the same spot. So the answer is going to always be, one of them is going to be 0, which means that it's factorable. Did I answer your question, Cole, or no? Okay. Sure. You want to divide both sides by 1.8 here? Yeah, I guess. And you're basically doing this step ahead. Yeah, sure. Awesome. Yeah, absolutely. You know what? I've never actually saw that, actually. You're absolutely right. Okay. Does that make more sense to you, Josh? Yeah? If you don't know how to factor, good question. That's fine. So it would be, yeah, it's going to be, I got to give myself more space here. X equals minus b plus or minus square root b squared minus 4ac all over 2a. Will this always work even when you can factor? Yeah. Okay, Nate, distraction, man. Minus b is going to be, I got to look here now. Minus b is going to be minus 27.8. So it's going to be 27.8 plus or minus b squared is 27.8 squared, but minus 4ac, the c is actually 0, right? So it's going to be minus 4 times 1.8 times 0. This whole thing just goes away, right? All over 2a, right? So you're going to get 27.8. What's the square root of 27.8 squared? The square root of 27.8 squared. Put it into gear first, man, before you drive away. 27.8 minus 27.8 is? That's where you get your 0 from. The other one's going to give you that. Was it 15.4? Does that help you well? Yeah. 27.8 plus 27.8 divided by 3.6. Okay. Once you get that, part B, I'm going to go to a new page because that's getting really long. Oh, I got to change the order here, don't I? I'll do that in a bit. Part B, how far would the police car have to go before it catches the speeder? I used D equals VIT plus 1/2 AT squared. No, why not? He doesn't have a, you can, but you'd have to figure it out, right? But it's not an average of 27.8. It starts at, how'd you get 27.8? It starts at 0, right? Doesn't matter my time, it's going to be 0. You could, well, that would be the same distance, wouldn't it, right? Yeah, that would work. I get 429. Lots of you had 426, which I found a little odd. I must have done so. I must have kept that 15.4. I must have kept the unrounded 15.4. Okay. And then the last one, how fast is he going? Yep. VF, VI plus AT. 0 plus acceleration. 3.6. 15.4, which is 55.4 meters per second. And I was surprised. I think there was only 1 or 2 people that kind of wondered, that seems pretty fast. I wonder how fast that really is. How do you find it in kilometers per hour? And you'd find that the cop car would be going, yep, 199.6. He's cooking with gas. Hey? Yeah, exactly. Yeah, he's cooking. Yeah, little ridiculous acceleration, right? Okay, so I sort of get the feeling that you guys need a little more time and maybe one more opportunity to do a question like this. Okay, so I've got to cook one up and get it to you. I suggest you do some book questions. I might even be able to find one in the book. I'm going to give you the rest of this period to work on problems. I'm doing components tomorrow. Okay? So, Keith, I'm doing components tomorrow. Okay? Have Noah return that little quiz. You guys in Grandview, you got the rest of this period. If you got other classes to get caught up on or whatever. But, yeah, I'm going to get these guys here doing another one of these problems. Okay, thanks, Keith. He's good.